everyone, I am Rakshita studying Electronics and Communication Engineering in Sri Venkateswara College of Engineering, Bangalore. Today we are going to study a topic of superposition theorem with an example. Let's move forward to the next slide. Introduction to superposition theorem. Superposition theorem is a powerful tool in electrical circuit analysis. It allows us to analyze complex circuits by breaking them down into simpler, easier to solve sub-circuits. The theorem is based on the principle of the linearity, which states that the response of a linear circuit to multiple input sources is equal to the sum of the responses to each individual sources. You can see the circuit diagrams A, B and C, in which it consists of three resistors, voltages and the current flowing through them. Statement of superposition theorem. Superposition theorem states that in a linear circuit containing multiple independent sources, the total response, current or voltage at any point is equal to the algebraic sum of the individual responses caused by each source acting alone. While all other sources are turned off, this means that each source is considered separately, with all other sources sorted for voltage source or open for a current source. The principle of the superposition can be applied to both DC and AC circuits. Mathematical representation of a superposition theorem. Mathematically, the response caused by a single source is found by considering that the source alone and applying the appropriate circuit analysis technique, such as Ohm's law, Kirchhoff's laws, etc. The response caused by each source is then added algebraically to obtain the total response. This can be expressed as total response equal to response 1 plus response 2 plus n number of responses, where n is the number of independent sources. Here also you can see the same diagram A, B and C consists of resistors, voltages and the current flow. Example circuit. Let's consider a simple circuit with two voltage sources V1 and V2, two resistors, resistor R1 and R2. V1 equal to 10 volt and V2 equal to 5 volt, R1 equal to 2 ohms and R2 equal to 4 ohms. We want to find the current flowing through the resistor R2. Let's move forward to the next step 1. Applying superposition theorem. Step 1. Turn off V1 by sorting it, replacing it with a wire. Calculate the current flowing through R2 due to V2 alone using circuit analysis techniques. Let's assume the current is I1. You can see it in the diagram in which V1 is sorted by replacing it with a wire, and then the current is flowing through it, and that is assumed as I1. Applying superposition theorem. Step 2. Turn off V2 by open circuiting it. Calculate the current flowing through R2 due to V1 alone. Applying superposition theorem. Step 2. Turn off V2 by open circuiting it. Calculate the current flowing through R2 due to V1 alone using circuit analysis technique. Let's assume the current I2. Now you can see that V2 is open circuited and the current is flowing through them, and the current is assumed as I2. Applying superposition theorem. Step 3. Find the current flowing through R2 by adding the current obtained in step 1 and step 2. Total current I total equal to I1 plus I2. Calculation and result. Let's substitute the given values in the previous steps. We know that I equal to V by R. So we are substituting in that formula by using Ohm's law. I1 equal to 10 volt by 2 ohms, that equal to 5 amperes. Similarly, I2 equal to 5 volt by 4 ohms, that gives 1.25 amperes by using Ohm's law. Therefore, the total current flowing through R2 is I total equal to 5 amperes plus 1.25 ampere, that equal to 6.25 amperes. Conclusion and the benefits of superposition theorem. Superposition theorem allows us to analyze complex circuits by breaking them down into simpler subcircuits. It provides us an efficient and systematic approach to solving circuit problems. The theorem is particularly used in circuits with multiple independent sources where other methods may become cumbersome. The voltage across or a current through an element in a linear circuit is the algebraic sum of the voltages or a current through that element due to each independent sources acting alone. Turn off. It means all the independent sources are replaced by their internal resistance. That is, we replace every voltage source by 0 volt and every current source by 0 amperes. Thank you for watching my video. Please do like, share and subscribe my channel.